Still nampak slide ni?
Boleh, Doktor.
Okay, good. Okay, Bismillahirrahmanirrahim. So today we will continue the first chapter, which is the non-linear equation for the third method, okay, which is the second method. And the other one is the Newton-Raphson. Okay, so last week we have covered the intermediate value theorem and also the bisection method. Okay, so today we will cover the second method. Okay, the second method is another iteration method. So still an iteration. Okay, it's an iteration method. So you need to doing until you get some the result. Okay, until the stopping criteria. So to approximate the root of a non-linear equation by repeatedly finding a second line of the equation. Okay, so some other term here is the second line. Who knows the second line? So the second line actually the linear line over here, which is passed through the intersect with the two points. Intersect at the 2 points. One is over here, and the other is over here. Okay, that is the second line. Okay, so if you can see from here the equation. Okay, so if you want to derive this equation, actually it's come from two straight lines. Okay, you can see this non-linear. Okay, non-linear, and then this is the linear. Okay, so this linear line, they call it as a second line. Second line. Okay, because of pass through the 2 lines, 2 points, one over here and the other one is over here. Okay, so what we need to do, we need to calculate until we get the value of non-linear line cross zero, which is here. Okay, at this point is here. So we want to find using the second line to find cross zero. Okay, cross zero line or the root. Okay, so actually this line, if you can draw again and again. So this is the first line. Okay, so later on the second line will be like this. Okay, the third line become blah 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 until we get at this point. Okay, so actually they have two lines, two straight lines. Okay, so this is the x0, this is x1, and this is x2. Okay, if you can redraw again. Okay, we want to find the gradient. The gradient. So we so now we have x1 fx1. Okay, and then we have x2 fx2, and also we have x0 fx0. Okay, so they have two lines. Please imagine this line. So this is x1, x0. So the gradient is x1 minus x0. Wait. Fx1 minus fx0 divided by x1. X1 x1 minus x0. Okay, so this is the first equation, and the other equation, so this is for the longest line, this line until this line. So then we have another line which is over here, x0 until x2. Okay, so since at the same line, the value is at the same line, so the gradient also will be the same. So you can write again fx2 minus f0, x0, and then x2, and then x0. Okay, and then we replace the x2 equal to x, fx2 equal to fx equal to y. Okay, okay. So this equation, once you replace the x and y, you will get, and rearrange, you will get this. Okay. Dia datangnya daripada dua line, tapi line tu datang line yang sama. Okay, satu line panjang, satu line daripada awal sampai sini. Okay, so dia ada dua line lah. Dua line, so line tu macam bertindih. So keturunan sama, you samakan. So then you can get the equation. Okay, so from this equation, so then you rearrange, you will get the value of the next iteration. You can get the value of x for the next iteration. Okay. So therefore, we will get another line over here. So for this, okay, so we will get a new x. Okay, for example, x3, yeah. Okay, x3 is over here, for example lah. Okay. So this is the equation. So if you can see from here, so to simplify, what I can say here, the table will be like this. So kalau ada siapa yang tak dengar, please let me know. If you don't hear me, please let me know. So the solution, you just need to replace the value to the equation. So before that, you need to have the table. Okay, for example, x. So ni nak padam ni, mencabar sikit ni. Okay, so the iteration number x, and then fx. Okay. Okay, so the starting from 0. Okay. Okay. So this is the value of x0, and then x1. This is fx0, fx1. Okay. To simplify from the equation, from this equation, okay. So we try to replace this as a B, C, D. Okay. So we replace the A, B, C, D into the equation. What we can get is xi minus plus 2 equal to AD divided by BC, AD minus BC divided by DC. Okay. So cross multiply, and then cross multiply, and then minus D and C. Okay. So if you forget divide by what, so you just take down the D to below, C to below. Okay. AD BC. AD minus BC divided by DC. Okay. And then you get this equation will find this value, x2. Okay. So once you get this value, x2, please take the x2 into the equation. Masukkan x2 dalam equation. And then the next iteration, for the next iteration, so the AB will be like this. So this one be A, B, and then this is the new C, and then this is new C. Okay. So until we get the result, okay, I try to draw again. So for example, the next iteration, so this is X3, A, B, C, D. This is FX3. Okay, until you get the result. Okay, understand? I didn't hear.
Yes, doctor.
Okay, I think
Yes.
I think this one is quite easy. Okay, you need to know that as an engineer, you must to know the formula is where it come from. Okay, so that is important. If you just know or just see this equation and then okay, I just use this equation. So once you forget, you blur. Okay, I think we need to see the example. I think this is very simple, second method. Okay, slowly we read the equation, the example. So the velocity of an upward rocket is given by, so this equation. So please remember that the y is the v. Okay, where m is the kg. Okay, the weight. So since I think the weight is the constant, and then a rocket at T0, the Q is the rate at which fuel is expelled, and U is the velocity at which the fuel is being expelled. Given the initial mass of the rocket, okay, so ni dah ada di equation, ada punya mass, M dah ada. The rocket expel fuel at the time needed for the velocity of the rocket to reach the 130, 130 milli per second, meter per second, by using a second method over the interval 10 and 11. So use the 4 decimal places in your calculation. So this is the stopping criteria. So once you reach this value, you need to stop the iteration. Okay, let's do it. So kita tengok kat sini Y. So the V is the Y. U tadi apa tadi? Mana tadi contoh ni? Okay, I think U is constant also, 1400. Okay. Ln. So the mass is 100,000. 100,000 divided by 100,000 minus Q is what? 1,500 T. Okay, T. Oh. And then minus G is the apa nama ni, gravity kan. Okay, mak ni tak nampak lah, kecil sangat. Okay, VT 100 per thousand ln 100k minus T minus 1.81 T. Okay, so this is we just replace the value, and then please be remember that to get the root, we need to make sure that the y is equal to 0. Okay, so the mention here is find the time needed for the velocity for the rocket to reach 130 meter per second by using a second method over the interval. Okay, so maksudnya kat sini bila dia reach, maksudnya dia sampai kat situ lah, sampai dekat dia punya kawasan root dia. Okay, so apa yang kita kena buat adalah kita kena, sebenarnya dia nak macam ni je. Dia nak jadikan dia kosong sebenarnya, velocity tu okay become 0. So how to become 0? So we need to minus the apa yang dia bagi tu lah, 130 tu. Okay, so this is the equation. Okay, so this is the equation. Mana ni pensel ni? Okay, so ni kita gantikan dia. Okay, so kita dah ada equation. So from this equation kita masukkan yang tadi tu lah, A, B, C, D. A, B, C, D. Nantilah kita dapat dia punya stopping criteria. Okay, mana ni? So masih boleh ikut lagi?
Boleh.
Okay, cantik.
Boleh doktor.
Okay. So sekarang kita ada kan, tadi kita kena gantikan FT ya. Sebenarnya ni FT. Sebenarnya FT ni sepatutnya kena sampaikan kosong lah. Okay, untuk dapat kosong tadi adalah VT tadi tu yang dibagi tolak dengan 130. Okay, so dapatlah FT tadi tu 140 ln 100k divide by minus T minus 1.81 T minus 130 Okay, so kita kena ada iteration lah. So the I and then dia ada T and then ada FT. Okay, for iteration, the first iteration, so dia dah bagi lah pada T kosong. Okay, pada T kosong, bila kita masukkan nilai T tu, kita akan berapa dapat? Initial dia lah. Okay, pada T pula. Dia nak interval interval dia adalah 10 dan 11. Okay, maksudnya ni 10, 11 ni yang pertama lah. So masukkan nilai 10 tu di dalam equation, kita akan dapat value dia negative 0.5405. And then for 11, okay, kita dapat 14. Apa soal ni? Kita dapat 14.5793. Okay, so this is A.
Excuse me, doctor. Excuse me, doctor. How can we write the value for T? The values come from where?
The value what? The 10 and 11.
Yeah.
So the 11 and 10 and 11 is come from the interval.
Okay,
the interval.
Okay, thank you, doctor.
So bukan there is not a T0 lah. Okay. Okay, the first iteration is from 0. Okay, so this one is C and then is D. So X, not X, is F. Okay, it's a F. Subhanallah. T2 T2 equal to AD minus BC divided by D minus C. Okay, for T2 we will get the 10.0357. Okay, so we write here 10.0357. Okay, then we will take the T value to the equation. So what we will get is negative 0.0083. Okay, so then we will do the next iteration. Okay, so this is the second iteration. Then this one is become A, B, C, D. Okay, for T3, okay, we will get the, so to simplify, so for T3 we will get the, okay, before that you need to see this one, this value. Is it less than 0.0005? If not, you need to proceed. You need to do another iteration. Okay, so since this one is not less than that, please make sure that the value is modulus. You need to you need to make sure you need to make it positive. So for the iteration 3, we will get 0.10.0362. And then this one become negative 1.0009. Okay, then still not reach the stopping criteria, you need to proceed. Okay, next one you will get the 10.0363. Okay, and now you will get 0.0006. Okay, so the interval is actually still less, still more, so we need to proceed. Okay, dah tak cukup pula sini. Okay, siapa boleh tolong kira kan? So this one is A, tak boleh tulis, A, B, C, D. T5. What is T5? Okay, 10.0362. Bahagi okay, so untuk yang ni stopping gate dia akan dapat jawapan yang sama. Okay, for T5, what you will get is 0.0363. Okay, so it means that whatever you do, you will get the same value. So this one is this equation so that show that the stopping criteria is not correct. Okay, so maybe dia kena buat 6 or 7. Okay, so that is the things. Okay, for the real equation, for the real example, the stopping criteria is not right, not written. Okay, there is no stopping criteria for this example. So some lecturer add this to just to mention that you need to do until the stopping criteria. However, the stopping criteria for here is incorrect. Okay, you can try to get to do more than more, and then I believe you will get I'm not sure how much. If you continue, you will get what number? same result 0.0006. Okay. Ni dan ni sama je sebenarnya. So 3 times 0.0 minus dapat kosong. So you get a 0 lah. Okay, you get 0. Okay, the next value T6 is 0. So sudah salah lah sebenarnya. Okay, so for the next example, I want all of you to do it together. Okay, Abdul Malik, Kev, understand?
Yes, doctor.
Mana yang lain ni? Senyap ni. So for the second example, given the graph 2x fx equal to 2x power of 3 minus 5x power of 2 minus 7x. Yes.
Nak tanya, kalau masuk dalam AD tolak BC tu, negatif tu termasuk tak? Ke tak ya? Negatif.
Ya, maksudnya kalau ada katakan ni nilai tadi 10.03, ni 10.02, yang ini ada negatif 0.09, ini 0.06
Ya. Dah masuk tak? Ke tak ya?
Masuk, kena masukkan.
Kena masukkan tak?
Okey, so 10.03 darabkanlah 0.06. Okey, minus 10.02. Okay, like this lah.
Okay.
Divide by 0.06 minus negative 0.09. Okay, don't remove the negative at here. Okay. So kena be careful lah kat sini. So I don't know why the meeting time is only less than 1 minute. Maybe after this we will you need to join again. If you can see here, the meeting will be end less than 1 minute. Okay, so before that I need to stop here. So we will continue again after this. Okay.